Hello friends, so I welcome you to the class of business to business marketing. In the last lecture we were working on demand forecasting and we talked about the two types of forecasting methods largely employed by marketers. One is the qualitative research method and the other was the quantitative research method. Now we explained the qualitative research methods like the historical analogy method, the Delphi method, panel consensus method, market research method. So all these methods we explained in the last class, and today we will be continuing and discussing about the quantitative methods of forecasting. So when we talk about quantitative forecasting tools, we largely talk about four methods, right? So, one is trend projection, then is regression analysis and correlation analysis, generally that is considered in one group, and then you have input output analysis and finally the econometric models, okay, of forecasting. Now, forecasting, this term forecasting is a universal term, right. So, it can be used for several purposes. For example, you talk about forecasting, demand forecasting, you can talk about inventory forecasting, you can talk about forecasting the future behavior of people, the forecasting the body sizes and shapes that would happen with time about because of our sitting habits, walking habits and all. So, forecasting can be used for any purpose, right. So, medical practitioners to scientists, rocket scientists, anybody, or sales people, anybody can use forecasting. So, when we are talking about the quantitative forecasting, what is the difference between the qualitative and quantitative, just to have a glimpse. So, it says quantitative forecasting takes the historical demand data and combines it with some mathematical formulas to predict the future, right. Now, what mathematical formulas? Basically, we will try to give some weight to the different times of different data points, or we will try to predict the coefficients that is used as per the regression models. So, what exactly we are doing, accordingly we will try to have a formula and try to fit in the data, right. So, when you talk about qualitative and quantitative, on basis of this the purpose, data type, approach and analysis, these they are different, qualitative and quantitative. So, for example, as we saw in the last lecture, qualitative data talks about answering the why question, why something is happening. We are trying to explore why did the person come to the store and he chose one product, but then ultimately he purchased something else. Why did he do that, right? Something else, that why do people, right, let us say give an answer which is not very authentic, right? What is the reason behind it? So, that why and then question is answered here. On the other hand, in the quantitative approach we are answering like how many products would be sold, how much would be sold, right, and what is the level of significance of the study. So, how accurate is the study. So, these things we are answering. And in terms of data type, if you see the qualitative data is mostly the as you have observed, or it is a symbol, it is a word. So, basically we do something like text analysis and all nowadays, sentiment analysis, text analysis. So, where we are trying to understand the behavior and other things, and here we are talking about some quantitative numbers, some statistical units, okay. In terms of approach, qualitative methods use a observational approach. So, you observe and interpret. So, how do people buy, when do they buy, what time of the year they buy, is it like affected by season, is it cyclical in nature. So, all these questions you observe and you try to interpret, and here on the other side you are measuring, let us say by let us say at one particular value of x, which is an independent variable, what is the sales, that is y, which is the dependent variable. So, you measure that and you are trying to test whether it is at what level of confidence you are answering, what is the significance level you are answering. So, you test that. Finally, when you come to the analysis, here you are basically talking about grouping of common data, trying to bring in all type of data into one group which are similar in nature, and then try to do some kind of interpretation. So, basically the analysis that is basically we do is more like a frequency and something, right. But on the other side, in the statistical analysis, we are trying to measure the level of confidence, as I said, the significance value and all, to check the accuracy of the data and how much it is affecting, how correct it is. For example, out of, let us say, in an experiment, we are saying 75% of the time the result will be the same. So, that means we are aware that 75% of the time, all the time, if you repeat, the reliability of the study says 0.75. So, all the time 75% of the time the same value will be repeated, okay, time and again if you repeat the test. So, quantitative forecasting now has several techniques again. So, for example, the starting one we go with is trend projection. Now, what is trend projection? There is a trend in the market, you are trying to project the trend. Let us say, giving an example, let us say this is simply the data. Now, I am fitting the data, let us say. So, now what I am doing is I am trying to see how the data is moving. So, I am trying to make a free flow of the a line which is crossing through the data points, and the variance is the minimum is out here. The variance means if you calculate the data like a regression line, the distance of the data points from the line that you have extrapolated, if you draw a trend line, then this distance would be the minimum, or the square of this distance, which is the variance, is the minimum. So, trend projection, what it says is, it uses your past sales data for demand forecasting to project your future sales. So, what was the demand in the past? Let us say if we have a data, say Tata Motors knows that from 2000 onwards, let us say it has a 22-year data of its various cars and their sales. Okay. So, it can now predict what will happen in the future, but now the question is, there are certain incidents that have happened, right. So, even those incidents can be incorporated by assigning certain weightage. So, that is what happens in a trend projection. It is a classical method in which concerns the movement of variables through time. Now, these are the, let us say, the time period, right, and this is the demand or sales, you can say, right, demand or sales, right. So, how it is moving across a various time period, thus demand or the sales, we can measure it. The assumption that it makes is that past trends will continue in the future. Now, whatever has happened in the past, that is 100% correct, that is an assumption. So, we are believing that exactly what was happening in the past will also happen in the future, okay. And then we try to just extrapolate the past trends and say ki this is the future projection, right. But all the time this may not be correct, okay. So, we have to be little wise and intelligent enough in our calculations, right. We may have to factor in things like sudden situations. For example, an inflation in the country has grown, the money market has is affected, or let us say there is a new disease or a natural disaster. So, these kind of situations also have to be incorporated, otherwise the data analysis would be wrong. So, when you talk about trend projection, basically we use a graphical method. So, as you must have done in your past, in your school and college days. So, graphical method is a method where you plot in the data and try to extrapolate it, right. Then you have a equation, fitting trend equation, and the third is Box-Jenkins method, which is a method used for small data or small periods of time. For this is not a long term data projection, this short term data projection technique, okay. So, let us go with this first one, graphical method. What it is saying? Under this method, annual sales data is plotted. Suppose our problem is sales data, we are talking about sales data, demand forecasting. So, we draw it on a graph paper and the line is drawn through the plotted points. A freehand line is drawn so that the total distance between the line and the point is minimum, which I explained. So, that this is nothing but the minimum variance. So, the variance is minimized, okay. Although this method is very simple and the least expensive, the projection made through this method are not very reliable, because what you have done, you have tried to believe that whatever was happening in the past will happen in the future, right. The reason is that the extension of the trend line involves subjectivity. Now subjectivity, as I said, inflation, the currency valuation, the diseases, the natural disaster, anything, right, and even a personal bias of the analysis. So if you are biased and you are feeling that it will grow in a certain speed or it will fall in a certain speed, that also can create a bias. So this is a, for example, a trend line. This is the trend line. The dotted one is the trend line, and we have tried to plot different data points. So as per the data points, movement of the data points, we can say कि this is how it will look. So in 2020, what would be the demand? Let us say. So we can measure through this plotted line and say कि 2020 we will be somewhere, let us say here, and this is our new prediction. The second is the fitting trend equation. Now, what is it saying? It is a formal technique of projecting the trend in demand. Under this method, a trend line is fitted to the time series data with the aid of statistical techniques. Now, let us do it. One, the form of the trend equation can be fitted is determined either by plotting the sales data or by trying different forms of trend equations. So, either you plot it like a graphical one or you have different equations and you use that. So, two types of generally equations, the trend equations are formed. One is which is very simple, linear in nature, and the other is generally exponential in nature. It can be sometimes even the data can be non-linear also, right. Many a times in fact in real life the data is not linear, it is non-linear, right. So, it could be, but we are talking about here two situations. One is if the data is linear, if there is a linear trend, that means there is an equal change, or there is an exponential change. Now, exponential change means where for one unit, maybe for one unit change in x, y changes by let us say 3 units or 4 units, right. Or in a linear case, if there is one unit change here, there is one unit change in y also. So, that is a second situation. Now, linear, what it is saying is when a time series data reveals a rising trend in sales, the following form is fitted, the equation is fitted, which is the simple regression equation, where y for example is the annual sales and x is my time, right, time in year or how many years I am taking to do something, right. A and B are my constants, right. So, A is called, basically A is called as intercept, right, and B is my slope, B is my slope, right. So, the parameter B, basically the slope, gives me the measure of annual increase in the sales. So, how much it is increasing or decreasing, whatever, that will come to that we can understand by understanding the value of B. Okay. On the other hand, the exponential trend curve says that when sales have increased over the past years at an increasing rate or at a constant percentage rate, then the appropriate trend equation will be an exponential trend equation, right. So, of the following type, for example, y is equal to a e to the power b of x, right. Example is your learning curve. Now, learning curve, most of you must have studied that when you use produce the first product, it takes certain amount of time and energy, but as you produce more and more, then this is called the Wright's equation. The amount of time that you will take will reduce substantially, right. As the number of production increases, right, the people will get more learned about the procedure and everything. So, they will take very little time because there will be no wastage, they have an idea about how to make. So, the hand becomes faster, the brain becomes faster. So, this is something where an exponential behavior follows. So, this is how you look like, for example, you see. So, the data is moving at a different pace, right, altogether. If you see, it is not a linear. Linearity would have been something different, but here it is going through an exponential form, right. The third method that we talked about is the Box-Jenkins. Now, Box-Jenkins method is used for forecasting only short term predictions. So, short term means up to maximum 18 months. So, 1.5 years, 18 months. So, such kind of predictions can be done by the Box-Jenkins because it is a very complicated method actually, right. So, it uses regression analysis on time series data. So, what Box-Jenkins method does is it uses regression analysis method on the time series data, right. Time series data, you must be knowing that where the data is mostly where we collect the data from different time periods for a particular group of respondents, right, like a panel data, right. So, Box-Jenkins method forecasts data using three principles: one, auto regression, then differencing and moving average. These principles are known as P, D and Q, and collectively this method is called as ARIMA. Now, ARIMA model, you must have autoregressive model, you must have heard about it. Now, this data, this method is this Box-Jenkins method is used here, right. So, it tries to calculate these three points, right. One is what is the auto regression, right, and what is the difference or distance, what you say, differencing, and finally what is the moving average. So, by understanding this values, we use the Box-Jenkins. So, you can this is one method, but it is used for short term data forecasting purposes. When you talk about time series, there are three other methods, for example, simple moving average, weighted moving average and exponential smoothing. These are the three popular techniques, right, which we are using. Because if you look at regression analysis, regression follows a linear method, but still in this case, in the Box-Jenkins case which you saw last, that there in that case what happened, you are using regression analysis for a time series data, which is generally not used, right. Now, what is a simple moving average? The moving average model uses the last t periods in order to predict demand in the t plus 1. So, last year's data is used, for example, to use or predict, let us say 2023 demand in 2023, year 2023. So, there can be two types of moving average methods, simple and weighted. So, it could be a simple, you do not want to give any weightage to any year and you feel equally they are all equal, or you can do a weighted moving average for a certain period of time, you can give more weightage and lesser, maybe the closest data is given highest weightage, and as it goes old, the data is old, so less and less weightage is given. The moving average model assumption is the most accurate prediction of future demand, right. It is a simple combination of the past demand. So, what it is saying, forecasted value for the t plus 1, let us say t is 2022 and we are predicting for 2023, right. So, what we are doing is t is that current period which is 2022, f t plus 1 is 2023, the next period, n is the forecasting horizon. So, this is right n, right, and a is the actual sales figure. So, actual sales figure in 2022, actual sales figure in 2021 goes on till what period of time. So, let us say 2015 I want to say, right. So, I will take that and then divide it by the number of years. Okay. So, using this method, this is a simple moving average, right. On the other hand, what we do is, this is the weighted moving average. So, what we are doing, we are assigning now weights, okay. These are the weights. All the weights taken together will be equal to 1. So, you may give the closest weight starting with, let us say 2021, 2021, 2020, let us say only 2019, 3 data we take. So, I will give 0.5 weightage, 0.3 weightage, 0.2 weightage, right. Now, how will you decide on the weightage? That is an expert's opinion, that is maybe your experience, your knowledge in the market, that will help you out. T is the current period, F is the forecasted period, N is the horizon, forecasting horizon, A is the actual sales, W is the importance given to each period, right. Then you have exponential smoothing. Now, exponential smoothing is a time series forecasting method for univariate data that can be extended to support data with a seasonal component also into that, systematic trend or seasonal component. Now, generally it is a is a powerful technique which is used as an alternative to the popular method, which we done recently, the Box-Jenkins method, which we discussed in fact. So, what is happening here? F t, that is the future value for forecasted value, is t minus 1 plus alpha into actual t minus 1 minus forecasted t minus 1. So, what was the difference between that actual value and the forecasted value for the last year, right, into a coefficient, a exponential, alpha. Alpha is the exponential smoothing component factor, and plus the last year's forecasted value. So, by doing this we can forecast the next year's value. Let us solve some problems. The past data for the demand of a product is given below. So, January 2019, February, March, April, May, June, July, right, given to us. Okay. If a 5 months moving average is used to forecast the next month demand, compute the forecast for the month of August 2019. So, July is given to you. Now, you use a 5 month moving average, right, and find out for August. Similarly, compute a 3 month moving average for August 2019, where the weights are 0.5, 0.3 and 0.2 for the other months. Okay. Find an exponential smoothing forecast for the month of August taking alpha as 0.33. Now, again alpha value will decrease or increase depending on what level of what kind of data you are taking. If it is a very recent data, the alpha value goes very high. If it is a old data, alpha value goes to close to 0, right. So, ranges between that 0 and 1. So, simple moving average. So, what I have done? So, f t plus 1 is equal to actual values, right, divided by n. So, simple moving average. So, we have used a simple moving average. So, we used 5 years data. So, here it is said to with using a 5 month average. So, 5 month, if you see 655 plus 747, you from this is the data, right. So, 655, so last 5, this last 5, right, 1, 2, 3, 4, 5. If you 655 plus 747, 862, 913, 963, right. So, 828 units. So, what we are saying is for the next August month, we would be having 828 units of demand. If you use the weighted moving average now, so in the last case you did not give any weight, right, now you are giving weight. So, what is the weight you have assigned? Now, 0.5 for the closest data, then 0.3 and 0.2. So, if we go back and look at the data, 963 is the closest, 913 and 862. So, taking the weightage 0.5, 0.3 and 0.2 and multiplying with respectively with the numbers, we get 927.8 units. So, for the same data set, for a simple moving average for the month of August, we got, right, using simple moving average we got this much, and by using the weighted moving average with a 3 month moving average we got this much, right. So, there is a difference, there is no doubt about it, right. Now, exponential smoothing, the third method. Now, what it is saying? So, January to again 19, so the values are given. So, using this formula, right, and alpha value was given to us, we can calculate. Now, f t minus 1 forecasted value, this one which is coming here, plus 0.33 into actual sales is 610. So, this is the actual demand and minus the forecasted one. So, this is giving us 592.58. So, the forecasted value for the month of March is 592, but actual was 655. Similarly, 613, if you calculate by the same method, this was 747. So, 786, 963. So, this is the forecast and the actual demand, right. Now, f t minus 1, this one 786.96 and alpha is 0.33, actual a t minus 1 is 963, right, this one. So, f t, the next forecasted value is now 786.96, this one f t minus 1. So, f t minus 1 plus alpha into a t minus 1 minus f t minus 1, right. So, which is equal to 845. So, if you use the see simple moving average, what was it? 828. If you used weighted moving average 3 month, it was 900 something, 927, 927.8. If you used the exponential smoothing, it is giving you 845, right. So, 3 different values are coming. So, now which is the closest to the actual demand, I do not have an idea, but one can always figure out, right, and accordingly they can choose the method they want to adopt. Okay. So, it is okay, this is what we have done. Okay. Now, what I will do is I will ask you to take it as an exercise. Check your monthly spending on, let us say, Amazon, or Amazon is just an example, on any online platform that you are using for purchasing, making sales, buying or something, for the past 6 months, and try to predict next month's spending using all the three methods. Why only one? Using all the three methods, right? You use it. Maybe you can take the same weights. If you use a weighted moving average, use the same weights of 3, 4, 5, 2, and if you want to make it different, then you can use your own weights also, no issues, right. So, this is a practical exercise that you please do it and try to complete it. Okay. The next thing that we will be doing is, I will not continue now because of paucity of time. So, but we will be talking about regression, correlation and input output analysis and econometric models, right. So, what regression is basically, and how regression equation affects. So, for example, we use a linear regression is y is equal to a plus b of x, and then what is x, what is a and b, how they are calculated, we will look into it in the next class. And what is correlation? Correlation is basically the relationship between two variables and how that also helps. For example, you have y and you have, let us say, x. So, what is the relationship between y and x? And let us say there is one more variable x2. Now, is there a relationship between x1 and x2? Let us say x1 and x2 are positively related and you have the data for x1. So, that means you can also predict if x1 impacts y and x2 also impacts y and both have a relationship, then with the data of one you can also try to get an idea about what will be the reaction with the other one, right. And also it helps you to give a R square value, which is tells you the explained variance in a model, right. That is also calculated through a correlation analysis. And then input output analysis, which is basically used for policy makers and all, and it was Leontief had given this idea about and he even won the Nobel Prize. I will discuss all these things in the next class, and till then take care. Thank you very much.